All right, we're gonna get started with relations and functions, part two. Today we're gonna talk about what is domain and what is range. So we're gonna try to simplify this as much as we can, but basically the domain of a function is the set of inputs determined by the x values. So basically, domain is the same as x, which is the same as your input values. The range of a function is the set of outputs determined by the y values. So basically, range are your y values, which is also your outputs. So looking at this example, the question says, what are the domain and what is the range of the function? So when it's given to you as a table, it's really easy to identify your inputs and outputs because they're just literally given to you. We can see that the inputs are going to be 1, 2, 3, 4, 5, and the outputs are going to be 11, 12, 13, 13, and 13. So if I ask you for the domain, all you got to do is list the x values, which in this case is 1, 2, 3, 4, and 5, and that is our domain. When it comes to doing the output, all you got to do is list the output values, which in this case is 11, 12, and notice that 13 is written 3 times. In this case, we're only going to write it once. My bad, that should say range. So your range is 11, 12, and 13, and it's that easy. All you got to do is list the inputs and list the outputs. So go ahead and take a few minutes and find the domain and range of those functions. All right, so those are the answers you should have gotten it. So for letter A, domain is 2, 3, 4, 5, 6. For range is 0, 1, 2, 3, 4. Make sure that you start with the lowest to the highest. Letter B, domain is -3, -1, 1, 3, 4. And for Y is 1, 3, -2, 2, and 6. Okay, so that is domain and range. Now, when it comes to determining the domain and range for graphs, it comes a little different. So this is the next question or essential question. What is reasonable domain and range, and what is continuous and discrete functions? So let's take an example. A host fills a 10,000 gallon swimming pool at a rate of 10,000 gallons per minute. So let's go ahead and fill this. Let's go ahead and fill this table up. So after 100 minutes, based on the information that it's given, 10 gallons per minute, 100 minutes, you're going to get 1,000 gallons. After 200, 2,000, 300 minutes, 3,000, and so on and so on. This is consistent, so it's going to be pretty easy to fill up. So 600, 6,000 gallons, 700 minutes, 7,000, 8,000, 9,000, and after 1,000 minutes, we finally have 1,000 gallons. Okay, before I tell you if this is continuous or discrete, and before we find the domain and range, let's go ahead and create the next function. So for letter B, we have a restaurant that needs 2 other chairs for its tables. One table can accommodate 4 chairs. So let's go ahead and fill this up. So if I have 1 table, I'm gonna have 4 chairs. If I have 2 tables, I'm gonna have to order 8, 3 tables, 12, 4 tables, 16, and I'm gonna go ahead and fill this up all the way. So 6 tables, 24, 7 tables, 28, and finally, if I have 8 tables, I'm gonna have to order 32 desks. All right, so the biggest question here is, should we connect the dots? And I wanna start with letter B because it's easier to visualize whether this is continuous or discrete. So we know that, you know, after when we get 2 tables, we have 8 chairs. But can we have, for example, 3.5 tables? Is that possible? Well, we could get some chairs. That's not the problem. But we can't get 3.5 of a table because we can break a table in half. If we break a table in half, it won't be a table anymore. So another example, can we have 5.5 of a table or 6.25 of a table? And the answer is no. So that would not be possible, which means that I cannot connect the dots because there's nothing in between. We cannot break a table. So in this case, this would be what we call a discrete function because we cannot connect the dots. Now, in terms of letter A, think about it this way. I know that, for example, every 300 minutes, we have 3,000 gallons of water. Well, let's look for a middle number. Can we have 450 minutes? And the answer is yes. We can break time into smaller pieces. We can do half an hour. We can do a quarter of an hour. We can do 1 minute, half a minute. I mean, we can break time as small as we can, which means that we could actually have something in between. So think about it this way. When we have for 350 minutes, we're going to have 3,500 gallons. When we have 380 minutes, we're going to have 3,080 gallons of water, which means that there is a bunch of points in between. So we could actually connect the dots, and that creates a continuous graph. So this is going to change the way we write domain and range. So when it comes to domain and it's given to you as a discrete function, we're only going to be listing them. So we know that my domain is X values. So I have a point at 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's nothing in between. So I'm just going to list those numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 9. When it comes to my range, I see that my range is 4, 8, 12, 16. And what I'm doing is I'm just matching where the points are at 24, 28, and the last one's at 32. So I'm going to list that as well. So 4, 8, 12, 16, 20, 24, 28, and 32. When it comes to a continuous function, I know that my domain, which is X values, starts at 0, which is something that I forgot on the other example, but it starts at 0 and it goes all the way to 1,000. Now, I'm not going to list all the numbers between 0 and 1,000. So I'm going to write that as an interval. Okay, so X is domain. And I'm going to write that as using inequalities. So I know that I'm starting at 0 and I'm ending at 1,000. For your range, we're going to be using the Y. And same thing, I'm starting at 0 and I'm ending at 10,000. So this is going to be 0 to 10,000. And that's how you're going to be writing domain and range. So to finish this off, the biggest thing that I want you to remember is how we write domain given a graph. So here's a few pointers. When we talk about domain, we talk about left to right. How big is this function from left to right? And we're always going to be using X and we're always going to be using inequalities. So if I ask you for the domain of this function, I want you to take a ruler or a pencil and tell me where's this function ending or starting on the left side using the X values. So I see that it starts right there. And that value is -1, -2, 3, 4. So this is -4. So from the left side, it starts at -4. From the right side, it ends at 1, 2, 3, 4, 5. Now notice that one of the circles is closed, the other one is open. When you have a closed circle, we're going to have an equal sign under the inequality symbol. When it's open, we're not going to write anything. So the domain of this function would be from -4 to 5. When it comes to range, and I'm going to erase this real quick. So when it comes to range, we're talking about bottom to top. All right. and range is gonna look like y. So what is the lowest point of this function? Well, the lowest this function goes is there, which is -2, which means that the bottom number is going to be -2. And there's no open circle. There's actually a solid line, which means we're going to have an equal sign under the inequality. Now, what is the highest or the top point of this function? Well, the top point is going to be over here. And notice that we're now using the y values. And that would be 1, 2, 3, 4, 5, which means that the top number is 5. But do notice that we have an open circle there, which means we're not going to have an equal sign under the inequality. So those are the few pointers. Again, this is left, this is right, and it should always be in that order. And this is bottom, and this is top. And that is domain, and that is range.